Hey guys, so in this part of the video we're doing the back of our note sheet. We're focusing on this question, which is how are we measuring water quality? So at this point we have already gone over the differences between pure water and wastewater and the different atoms that are involved in wastewater compared to pure water. So now that we have an understanding of what kind of atoms are in wastewater, we can start to better understand what these tools do for our water filtration measurements. So let's first start with the Tds meter. So a Tds meter measures how many solids are dissolved in the water. It's usually measured in parts per million, or short ppm. And the Tds meter measures things like charged particles, some metals, but not all, and salts. Range of measurement is how big, or how the range in which the meter measures. So it goes from 0 ppm all the way to 999 times 10 ppm for our Tds meter. And for the examples, let's go ahead and compare pure water to wastewater. So first let's draw an image of pure water. So pure water only has H2O. That's all it has. So the total dissolved solids, if you were to put the measurement in here, it would not detect any of these charged particles, metals, or salts dissolved. So the TDS would be very low TDS. Now let's draw wastewater. So as you remember, our wastewater had a ton of different particles in there, right? We drew this, so I'm gonna go ahead and draw it so that it represents the different particles. So let's see, I'm gonna go ahead and put H2O, but I'm also going to add the Na. So this is the color for sodium. I'm going to add hydrogen. I'm going to add the food coloring. Oops. And I'm going to add chlorine. So basically these colors are just representing the colors that I used in the front of my notes. If you don't have colors, that's okay. You can just draw particles like I am, and those particles are going to represent all the contaminants. So because there's so many other things in addition to water in this reading, this actually is going to have a high TDS value. Alright, now let's go on to conductivity. So conductivity measures if the water will conduct electricity. It will conduct electricity if there are charged particles, dissolved in the water. And some examples of that would be H+, Na+, Cl-, CH3, COO-, which we drew on the other side of our paper. So the range of measurement for conductivity, 0 MA means that there's no conductivity. And it could go all the way up to 10 milliamps, which is very high conductivity. Now let's draw some diagrams to help us understand what's going on in the water. So first we'll draw pure water. So in pure water, it's just H2O. H2O molecules are not distinctly positive or negatively charged, so there's no charge, so there's no conductivity. So it's 0 MA. Now let's draw a picture of the wastewater. So in our wastewater, we had some charged particles, right? Remember, we had Na+, Cl-, food coloring is negative, and so is acid. So we're going to go ahead and draw those out. So I have Na+, Cl-, I have the acid, CH3, COO-. I have food coloring that's negative. And I also have H+ from the vinegar. I'm going to go ahead and give this some color so that it's easier for you to remember. Cl- came from salt. Na+ also came from salt. Food coloring. And CH3COO came from the vinegar. There. And so because there's charged particles, these are positive and negative, depending on how many of these are available in the water, it's going to have conductivity. So conductivity will be greater than 0 MA. So it'll be bigger than 0 MA. Okay, so now let's go over pH meter. So the pH meter measures how acidic or basic, actually I'm going to change that, measures how many H+ ions are in the water. The more H+, the more acidic the water is. Alright, so H+, remember an ion, if you don't remember what that is, an ion is a charged atom. So basically these up here, these are actually all ions. There's another vocabulary word for you. And H+ is a type of ion. And so pH is a measure of how many of these H+ ions are in the water. pH can range from 0 to 14.00. And now let's draw the drawings for pH. So in pure water, there's actually just water, and the pH is usually 7.00. There's kind of a balanced number of H+ ions, and it's not acidic. Now let's draw the wastewater. In the wastewater, remember that from the vinegar, right, we have these H+ ions form. So the vinegar, the more vinegar is left, the more H+ ions there are. So if your water filter filters out most of the H+ ions, the pH will be not as acidic. So if there's more H+ ions, the pH will be actually less than 7.00. The fewer H+ ions, the higher the pH. Alright, now let's talk about the turbidity tube. And by the way, in the wastewater, there's all these other molecules and atoms, but I'm not drawing them because I just wanted to focus on the atoms that affect pH. All the other atoms, like the food coloring and the salt, they don't really affect the pH range. The only thing that affects pH is the H+, and that's why I'm drawing it here, but just know all these other ions are still in there. Alright, the last one is going to be the turbidity tube. So I'm just move this out. Alright, so the turbidity tube. The turbidity tube measures how clear the water is based on how much solid particles are suspended or dissolved in the water. It also depends on the amount of light that can get through. The water. Alright. And the turbidity can actually range from 0 NTUs all the way to 250 NTUs. Now let's draw the diagrams that show the differences in turbidity. So in pure water, you just have water, just plain water, and there's really not many particles that's clouding up the water, so the turbidity is very, very low. It's probably less than 5 NTUs. But in wastewater, we have a ton of atoms and molecules and things floating around, right? We have water, we have Na+, we have Cl-, we have food coloring minus, we have CH3CO- and H+, right? And let me just highlight those because I think it will help you understand it better. So here's the food coloring, here's the hydrogen, here's the CH3COO, Cl-, and Na+. Because there's more particles in the water, it's probably going to cloud up the water more. But again, it depends on the size of the particle too, because some of these ions, they're so small you can't see them. Such as salt. When you dissolve salt in the water, it turns clear. So it really, I think this will depend on the number of food coloring molecules. But if there's a lot of those molecules still in the water, the turbidity will be high and it'll be a bigger number. And that's it.